Alright, welcome back to our regularly scheduled programming. Thanks for tuning in. Alright, so here's our continuation of Tuesday's lab, which did not go very well. I'm sorry for that. We have fixed up the data now. All should be well. Alright, we're going to pick up where we left off there in lab. We turn to our Canvas page here in the instructions. Takes you to our procedures and where to download the data. If you scroll down now, grab your data from the appropriate section here. Should be good. Okay. Now what I did was I got rid of all the leading zeros and trailing zeros that made all those functions not work. Okay. And now they should be good, as you can see here. And try to blow everything up so it's bigger so we can see what's going on. But here it's tougher to see down my little tabs here. We got no shoes fast, no shoes slow, shoes fast, shoes slow. All right, as well as our static page. Okay, so here's everything we need to knock this lab out. If at any point I start moving too quickly, please pause, rewind. I just want to try and get through this. It's kind of late here, and I'll try and cover everything that we should need for one of these conditions, and that you should be able to copy and paste in the rest. We'll actually show that as well. Yeah, so let's get right after it. So first things first, on the realist. Come on down here, we open the static. We need to determine the average body weight of the trial. The reason is we're going to normalize all these variables to this person's body weight. That way we can compare between individuals. If you don't compare, then you're just getting these raw Newton forces here. And if someone has more mass than someone else, then Newton's second law there, force equals mass times acceleration. They can be moving slower but still exert more force on the plate. And then good luck comparing Yao Ming to Simone Biles. Like it just doesn't work that way. You got to put it in terms of their body weight, right? Then we can change everything to like percentage body weight. You can think of it that way. So first things, we need this average body weight. Pretty simple in Excel. Anytime you have a formula that you want to use, anytime you want to use the big calculator that is Microsoft Excel, you have to use this equal sign. All right, that tells it I'm not typing just letters in here, right? I'm actually giving you some math I need you to help me out with. In this case, to call the function, we type in what the function's name is. In this case, it's average. Then you open up the parentheses here, and this is where it takes arguments, or you can think of it as inputs for a function, right? We have inputs, function chews it up, has an output. Our output is going to be the average of this whole column here. Now, I could drag down all the way to the bottom, but that may take a second. There's a lot of numbers. If you click on this first number here, right, this 805, if I hold on a PC, Control Shift down, then what I get here is it highlights everything all the way to the bottom. Okay? If you're on a Mac, that would be Command Shift down. Okay? Either way, it highlights everything. Close your parentheses up top. You can see that it did so in my formula bar up there. Hit enter. And there we go. There's our average body weight in newtons. All right. So what we're going to do here, head to this first tab. This is the no shoes fast condition. No shoes fast, no shoes slow, shoes fast, shoes slow. This no shoes fast condition first, we need to calculate here is the normalized ground reaction forces. So this x variable, that's our medial lateral in the lab. We don't care about that. Y is anteroposterior, front and back. That's important in terms of braking and propulsion. And then there is the z, that is the vertical component. Obviously, we have vertical ground reaction force from us impacting the ground. That's what's going on here. All right, so we're going to normalize these. What I'm going to do is I'm going to call this norm Fy. Then we're going to have norm Fz. Okay? And we could... Yeah, we're just going to go ahead. Well, no, we'll take care of that in a minute. So, now our units over here are newtons, time and seconds, but we're not in newtons for this. Again, now we're going to be in terms of body weights. Okay? So, this is all be percentage body weight. And the way to work is we could take this number here in the y column. We're going to end up putting over here and dividing each one by that body weight. So that's how we normalize to it. But we have to do it for each row. That would take a while to do by hand, seeing as how there are, 648 rows for this column, so we're going to ixnay on that. Again, we can use a formula here, equals, and what I want to do is divide each one, start with the first, slash for divide, go back to our static page here, click here, and you can see in the formula bar what it's doing is it's going to that column on that page, dividing by E2 here on this page, the static page. Now, with Excel, when you want things to hold still, which we do, and actually I'll demonstrate. If I hit enter here, it goes back to that first page. That's good. That's 0.006% of a body weight. That's fine for the first one. If I drag down, errors. Why? If you look up in the formula bar, we didn't lock down that spot where the average body weight was. This is an E2. But if I come back to this formula, as you see, as we go down, it goes down with whichever row of the column it is. So that's not going to work. The way you get stuff to hold still in Excel is you throw money at it, okay? This is the one thing I want you to take away. So up here in our formula bar, I want E2 on that static page to hold still. That's where our average body weight is. I'm going to put a $sign in front of the E and a $sign in front of 2. That tells Excel that this part of the equation up here, I don't want it moving. All right, I don't want the E column to change. I don't want the second row to change. I want you to always get from E2 there. And that's that. So now, if I drag this down a bit, life's good. All right, so once we get that first one done, to copy it all the way down, you could highlight it and drag it all the way down, or Excel is a nice way of looking to its left or right, saying, oh, you've got this many rows of data. If you double click this little green square in the bottom right corner, it's so tough to see, but there's a little green square there. If you hover your cursor over it, it should turn into this black cross instead of the white cross where it's everywhere else. If you double click it, it should copy that all the way down. All right, life's good. And now, guess what? I can copy that, Control C, paste it right next to it. Does the same thing because Excel works by saying, oh, for this cell over here, for your formula, you looked 2 columns to the left and divided it by that static body weight. And then for this one, when I copy it over, it's still going to look 2 columns to the left, divide that by the body weight on that page. All right, life's good. Now what I'm going to do, I should have another one open. This is my cheat sheet. You guys don't get my cheat sheet. All right, these are the big variables we are working with here. I copied them straight out of the page over here. So we're looking for the ground reaction force at initial contact, all right, in the Z direction here, as well as the time when it occurs. I made that easy for you by cropping all the data. You're welcome. The maximum GRF value, the time at max, the time at toe off, and there's time at toe off. Yeah. So we're basically capturing these ground reaction forces at certain events as well as the times when these events occurred. Okay, so first one, very simple, very, very simple. At initial contact, and this one may make sense if we actually just graph this real quick. So we've got our forces here. You can see Y is blue. This actually brings up a good point. We know that our AP force should start with a braking force and end with a propulsive force. And the way that looks in our coordinate system, we should start with a negative blue line underneath 0 here that then turns positive. All right, and what that means is this braking impulse, this area under the curve, in the beginning it should be negative, right? Because our leg's out in front of us, it hits the ground, and the reaction force is back towards us from our front. So it's got to be slowing us down, right? And then as we transition through mid-stance, our shin goes over the ankle at some point. We're pushing towards our behind us, and then that reaction force will propel us forward. So what we found is that this reaction force is no bueno, and guess what? That's an easy fix. Come over here to this formula here. For the norm, we set all of this, then tack on here, times -1, so star -1. All that's going to do, flip the sign. You can see it already changed in our graph. Beautiful, okay? So variables we're finding for ground reaction force. We need at the very front here, what is the ground reaction force at initial contact? Then we need the peak vertical ground reaction force. That should be this guy right here, around 1.75. And then we need the value at toe off. Okay. Now I'm going to show you how we're going to find initial contact. Brace yourselves. It's this guy right here. Okay. Until you hit the force plate, it's going to read 0, right? The first number you get reading wise from your force plate that's not 0 should be your ground reaction force at initial contact. So thank you for coming to my TED Talk. That was simple as that. And guess what the time is? Same thing, just in the time column. Not bad, huh? All right, and if you, for some reason, I don't know why people keep arriving at some of these like subframe, right? Like some of those Excel sheets we got earlier, they were like subframe, you didn't get this, and it was like 1, 2, 3, 4, and it has to do with the way that our force plate like down samples to whatever other devices we have in our system. You got to have them all in like the same number, like multiples, and it's all hogwash. I tell you what. If it looks like this, well, we're going to talk in terms of time today, so we'll change that column to here. Change this to seconds, and we are sampling at 1,000 hertz. Okay, that means our force plate takes 1,000 snapshots every second, and has a data point at each one. So what is 1/1000th of a second? It is 0.001. What's a second? 2 divided by 1,000. That would be the second frame. All right, and then to get that to go all the way down, highlight the first couple, double tap the bottom right corner. Well, that's just because I had data that far, but it should auto-populate all the way down. Beautiful. It's all in seconds now. And it shows up here, and we say equals to that. Good, good, good. Okay, now, GRF max. Now we want the biggest value. I'll give you a hint. Equals max. There you go. Returns the largest value. Now we just need to get it from the right column. That would be this F column. The normalized Z is the vertical. That's what we want. Highlight everything. Boom. Enter. Now, the problem here, even though this is the right answer, will come later. If I scroll to the very bottom, we see that there's 648 rows. If I go to the bottom of our next one, there's 690. That is more than 648. So, if I keep this same formula here, it might not find the max if it comes after 648 in the next one. So we happen to do it in the shorter one here. It's simple in Excel. If you really don't care about this range in general and you just want the largest number in the F column, which guess what? This is our norm vertical force is all we have in the F column. That's fine. Go up here to your formula and make it say F colon F. That's what we want the max of. F colon F. Still gives us the same thing. So now it's just saying look in the F column period for our biggest number. Okay, now this one's a little funkier. Now we need the time at this number. Now you could just scroll down until you find that 1.7219 whatever, and then look over in the time column and see what you got. I do not want to do that. We have a big fancy Microsoft Excel to do it for us. So the function we'll use here is X lookup. Okay. You open the parentheses here, it'll say, give me a lookup value. What do you want me to look up? I'm going to look up this maximum right here. Then it's going to say, where do you want to look it up? In the F column, F colon F. Then it's going to say, what's your return array? So now it's saying, all right, I'm going to look in this column, and when I find this match, I'm going to say it's in the 1, 2, 3, 4, whichever spot. Then I'm going to look in my time, or I want it to look in the time column and find me whatever time it was at that value, okay? So I give it a colon A. That's where I want to look it up. Close your parentheses, hit enter. So this maximum ground reaction force for no shoes fast was occurring at 0.124 seconds into our trial. Simple as that. All right. Now this one's a little funkier. This one, it's basically asking for what's the value at toe off, which means we need the last value in the column. But again, all these columns won't be the same length. Some trials, when you step on the force plate to when you come off, more time or less time elapses. Like the foot's not always on the force plate for the same amount of time when you're walking or running over it. So we're going to use this funky guy right here. Ignore the number that just went in there. Look at the formula here. It's a gross boy. All right, so this says look up, and I'll be honest, I don't know what half these mean. Just pause it real quick, type this stuff in. What it gives you back. This is the first thing I Googled and it popped it up. This gives you the last number in this column, or in whatever column you tell it to. I'm telling it the F column because I want norm vertical column. We hit enter, gives us the number. That's all you need to know. Then we want the time. Again, when you want the matching spot in a column, the matching row in a column from a different column, we use XLOOKUP. So I want equals XLOOKUP. Find this number in which array? The F column. That's what array means. Array, column, row, they're all the same. From the A column, A colon A. And this happens at 646. And is our last number 646? And is it this? Yes, it is. We're done with all the vertical stuff. Okay, so not bad. Those are what we needed there. Now, right below it, I'm going to paste the values we need going on from the anteroposterior column. This one's a little trickier. If you remember, it makes like, well, I mean, I'm going to have to tell you. I can just show you. So it's flipped. We have this braking proportion here, right? The braking force. Then it crosses 0, at which point is mid-stance when it crosses 0. And then we have propulsive force in late swing. That's when we start to press off or leave our stuff behind, So we need to find this maximum or minimum here, right? This dip, the peak braking force, right? We need to find this peak propulsive force right here. We need to find mid-stance. And then we need the times at each of those, okay? So we've got these 8s, and then the ground reaction force at toe off and initial contact as well. So here's the initial contacts from up there. If I copy and paste, what happens? I don't know that stuff, but that's okay. Actually, we didn't have to copy and paste anything. It was hogwash. So equals first one. Done. Equals first time. Notice not much change, huh? All right. Equals. Now we're finding the minimum. I'll give you a hint. Minimum function of the E column. Survey says that's what we got. Then we got the time when it happened. Our good pal, XLOOKUP. What are we looking up here? We're looking up this value, the minimum value. Where can we find it? Probably in the E column. And what do you want to return? The time when it happened from the A column. Thank you. Come again. Good night. All right, then we have time of, and I just typed in mid-stance here. What is it over here? Mid-stance when it switches from negative to positive. This one, oh mama, let me tell you, it's a bear. Buckle up. And actually, I have just the slightest bit of tweaking to do, but it'll work, trust me. So, E column here. Nix these, because we had an issue with another one that I needed to fix, but you guys won't have that. Or you might, I don't know. This is what we get. This is saying use XLOOKUP as well as the index function. We're squishing functions inside functions here. It's gross. All right, but copy this, paste it in the same spots. Life will be good. It's basically saying, like in this index function here, it's just saying look for numbers that are greater than 0. So it's kind of finding the first spot where you get zeros. And that works out for this one because we go straight from the beginning into negative numbers and we pop back up into positive at mid stance. Okay? So this formula works. This formula does not work. We have to start at E2 at least, or E3. Yeah, my bad. Dial it back there. So up here where you see E's, we got to start them at E3 and go until at least and we'll say 1,000. Because I don't think any of these are 1,000 data points long. So we're basically just making sure that Excel covers all the stuff that needs to be covered here. And then from there, now it works. Now we got the time at mid stance. Boom. All right. So I'll go back one more time. There's the function. Gaze in wild wonder. That's a beauty. All right. Find the max. That peak propulsive force equals an X equals a E column. Give it to me. Thank you. Come again. Not a lot going on there. Is that right? I'll be a monkey's uncle. That was a weak one. Well, granted, it's never going to be as high as a vertical ground reaction force. I don't know what I was thinking. Then the time it happens, X, look up. This is what coding does to a mofo. You start talking weird. Where do you want to look it up from? E column. Get the match in the A column. Dunzo, thank you. Plus, it's getting late here. That's why I'm partially getting a little. Alright, so here, last one. We're going to copy this same formula from up here. This Z at toe off. We want the, not Z at toe off, but Y at toe off. You know what I meant. Copy it. Paste that formula here. And now I'm going to come up here and change where it says F columns, E columns. F columns, E columns. There you go. YE column, in case you guys were following, that's where our Y values are. Normalized Y values. And then, you guessed it, X lookup, save the day. Tell me what time we happened at. Pretty please. Oh, thank you. Alright, that's it for one condition. Now, guess what? If I do this for all my sheets, I will get all the right numbers. And if not, we riot. So all I did was I clicked on the tab up here and dragged across. Click on E, drag across, include everything we need. Copy. Control C on a PC, Command C on a Mac. Once that's copied, I'm going to come over here, click on E, paste. Now what you'll notice there, before I zoom back up, it did not paste all my values all the way down. Why are we short here? Well, because that other trial only went 648 rows down. What can I do to alleviate this? Highlight these last two in the E and F columns. Double click the right corner, that little green guy. Bob's your uncle. We now have all the data we need. Are these numbers right? Of course they're right. Why would I lie to you? Well, that time at toe off is not right, so actually I'm right. Ew, oh, I don't know what happened here. All I gotta do is fix this. So again, highlight these once you get a sequence going of 0.01, 0.02, which first of all, they should not be 0.01, they should be 0.001, 0.002. Who did that? Double click, should go all the way down, and that changed them. That's about right. Alright, so go ahead and do that, copy them all over again. When you're done copying all these over for this sheet, this sheet, this sheet, this sheet, then what you can do is make a charts page here. And the way this charts page will go, you'll come over here. You'll highlight these two columns, copy, you right click copy, take your, if you're on a laptop, 2 fingers in the bottom right corner for your Mac, that's right click, it's weird, I don't get it. Control C, don't care. Take them, put them over here. We'll put them in the B column first. And actually, let me dial this back, yeah. B column here, paste special. Yeah, we guess you don't want the values only. So on my PC here, it looks like this little clipboard with a 1, 2, 3. On a Mac, it might just have like a list and in there is values only. Click that because if not, it'll try and do the formulas and there's nothing else for here to draw from on this sheet, so you'll get errors back. So that's all you do. Then we go time, seconds, 101, 102. Double click and get it all the way down. That's good. Well, the time you'll have to drag out if it's not the longest one, but you get the gist, all right? So you're going to end up doing that for both of these. You're going to end up doing it for all of them, but and there's what happens if you don't copy paste it special. So control, paste, values only. And if you don't, you'll have problems. Now what I want to do is come up here to this first column, click on like the one header here so it goes all the way across the whole sheet. Insert. This way I can highlight these and let you know what they are. So like this first one is no shoes fast, right? Second one is also no shoes fast. Then the next one is no shoes slow. And make sure you do that over. And when you do it for all of them, guess what? You can highlight all of these. Daddy lied. Daddy lied. Don't do that. You got to keep them a little separate. What I'm doing here is I'm cutting. We're going to have to move the Z's off to themselves because we need two separate graphs here. We need a norm of the Z and the norm of the Y with all the shot, slow, fast, blah, 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 blah. So go ahead and do that. Now you'll be able to label each one. And then from here also make sure time goes out. Oh, make sure time goes out. Double click it once we add the new one. Make sure it goes all the way. Once this goes, once it's in the right spot, you can highlight and we'll end up adding another. Add the other time column over here. All it takes to create those graphs, highlight across, using the ABC all the way. You should have D and E by the end, so you should have no shoes fast, slow, shoes fast, shoes slow. You'll come up here to insert, go over to recommended charts, this one, the scatter plot, and do the smooth lines. Life is good. Right, this is what we want it to look like. Bingo bango. You'll have a little legend down here. You will have to add things. Here I have the little quick add. I can do access titles here. Chart title, blah, blah, blah. You can also add them up here under the chart design tab in the ribbon. Okay. We're going to need to name these, so this will at least have to be the AP ground reaction force. All right. Then over here, we know our units are in body weights. So this is really force, but in body weights. So we know these are in like percentage of body weight, right? And this is time with seconds as our units on the x-axis. That's a good graph. I mean, it's short a couple of trials. You guys got to do those, but otherwise it's a good graph. Guess what we do for the other one? Exact same, highlight two, insert these, boom. There's your vertical ground reaction force. There's your get a typical double peaks, somewhere mid-stance around here. Bingo, bango. Again, make sure you add access titles. You can do it here or here. Chart title, this one we can call vertical GRF. Don't know what that was. Same force body weights over here. Time in seconds down here. That's it, guys. There's also a quiz associated with this. Please go do the quiz. There's questions related to this. You don't have to make the table here for me if you just make your table on each one that you copy paste over this guy. That's fine. You might need to use this for your answers in the quiz, but as long as you got it good, make your charts. Do me proud. Again, these data should be good now. Happy hunting. You got any questions, email me.